Good afternoon, everybody. You are watching the ThoughtWorks Google Hangout on deploying and operating microservices. Hopefully that's what you were expecting to see. My name is Scott Shaw. I'm the head of technology for ThoughtWorks in Australia, and I'm going to be facilitating the chat today. I'm going to throw out some questions, and we would like to take questions from you, the viewers of this live stream as well. So feel free to type them in there, and we will try to keep them concise so that I have time to read them while we're going through this. Microservices. We're going to talk about microservices today, but we wanted to dive into a specific topic. Microservices really, to me, represents a general shift in the way we've been building applications over the last few years, particularly at ThoughtWorks, and we communicate with our colleagues around the world quite a bit. We've moved from building monolithic applications to building applications that keep a lot more state in the client and communicate with a variety of services on the back end, and then those services communicate with each other. They can be large or small, but in general, the way we build and deploy those has changed a lot. It's driven by mobile, cloud, the DevOps movement, things like that have made all of this possible. So we've seen a lot of talks on microservices, a huge upswing of interest over the last year in this topic, microservices, whatever they mean to people. It's definitely, we can tell by the Google search terms that there's a lot of interest in it. And we've seen a lot of talks, kind of general, here's what microservices are, here's the things you need to think about when you're building microservices, here are the basic principles. And we want to kind of move beyond that today. We would like to move beyond that and get into a deeper dialogue about some specific topics. And we'll be having more of these Hangouts, and we can get into other topics in more detail as well. And the topic we want to focus on today is specifically around deploying and operating the microservices. So with me today, we have two other guests. The first one is Sam Newman. Sam is a consultant in Australia. He works out of our Sydney office, but he goes around the world a lot. He's a frequent traveler. Sam has recently published a book called Building Microservices. Do you want to show us the book, Sam? There it is. It's a book by O'Reilly, put out by O'Reilly, and it's brand new, and you can go and download that, or you can get even the print version. Also with us is James Gregory. James is another consultant in our Sydney practice in Australia, and he has had a lot of experience with these things. He's been involved with a number of projects over the last few years. Almost all of them have involved something that you might call microservices, with lots of small services communicating with each other to solve a bigger task. So I will stop talking now and throw the first question out. I think we need some definitions. We probably need some definitions. So as the first question, I would like to ask Sam, what are microservices? I think we don't want to dwell on this a lot, but I think we want to have some basic ground rules and definitions before we get started. So Sam, what is a microservice to you?
I tried lots of different definitions. I think the one I like the most is one that Ben Christensen from Netflix gave me, which is that there are small autonomous services that work together. And sort of in that definition, you get a sense of almost the inherent contradiction of that statement. You know, on the one hand, you have these services that need to have a high degree of autonomy. You can change, operate, and deploy them independently of any other service, but they've still got to work together with other services. And trying to walk that fine line is a source of a large amount of the complexity associated with them. James, do you have anything to add?
That makes sense to me. I agree with that. I think the only thing I'd add to it really is qualities of a microservice. You're quite likely to see multiple technologies in there. It's not a requirement of a microservice, but I would be surprised if you didn't have multiple technologies involved in your stacks. Perhaps, well, likely the people who built the services should be looking after the services in production. It's not necessarily a thing of a microservice, but that's something I'd expect to go hand in hand. And the services themselves should only really be doing one thing and doing one thing well. That's kind of what I would add to that definition.
Thanks, James. If you could continue, and since we're talking about deploying and operating microservices, what is it about microservices that makes them unique in terms of deploying? Why is deploying a microservice service different than any other piece of software?
So I'm not entirely sure that microservices are a whole different beast to deploying other software. The thing that I see about microservice architectures and how we deploy them is that all the practices that we've been talking about for years and years about deployments being separate and services being autonomous and not tying yourselves together with other projects and doing lockstep releases and having high levels of confidence with the quality of the service that you're deploying and the quality of your deployment process. And we should be doing those things for any services that we build, but we're kind of able to get away with and be a little bit lax there sometimes when we're only deploying one or two things. And it's so easy to just patch something up after the fact if the deployment didn't quite go right. But when we're doing microservices, that becomes considerably harder to do. When we're operating at the kind of scale that we talk about when we're doing microservices, we've got to be really, really good at all these things that we keep saying we should be good at. So for me, it's about rigor around it all rather than being a completely different beast.
Yeah, it's a different problem when you're doing this on a mass scale than when you only have a couple to maintain, I'm sure. Sam, here's a softball question. Do we want to have, if we only have one machine, do we want to deploy lots of microservices on that one machine?
Yeah, it always gets a little bit sketchy is what we mean when we talk about a machine with virtualization and containers. I strongly prefer a unit of operating system isolation for my microservices. So that might mean if I've only got a physical machine, one microservice per machine, or a VM, one microservice per VM, or a container, one microservice per container. The reason I like that model is it reduces side effects of deployment and configuration of that microservice. It makes monitoring more easy because I can look at the CPU coming from that operating system unit, and I can more strongly correlate that with the behavior of that service. Often when we pack, say, multiple services onto the same machine or within the same container, say application container, for example, we frequently see issues where a change to one service impacts the other because it maybe gobbles up all the CPU. I spent many days looking at application containers that are just locked up entirely. And so in general, I like that model where I've got one unit of operating system isolation, one microservice. Obviously, that gets quite expensive if you don't have a way to slice up your machines into smaller parts. Virtualization helps there, as does stuff like container-based technologies where you can more densely pack lots of isolation units onto a single piece of physical infrastructure. And so that's, I don't think it's essential. I think it's something that you inevitably want when you get to a certain level of scale. I think maybe you can get away with it with one or two or three or four services. When you're looking at, say, 15 different distinct types of services, that's when this stuff really starts hurting you. And most organizations, well, in fact, every organization I know that operates at scale has that unit of separation. Yeah,
so it's virtualization, I think, is really important to this topic in order to get that isolation. And people are deploying all kinds of software, lots of people to the cloud these days. And I wonder, James, is there anything unique about microservices that make them particularly suited to the cloud?
I think that's a good question. Yes, I think there are several things about microservices that make them particularly well suited to the cloud. We're building a lot of small things. We want those things to be quite changeable. We want a lot of control over how they're deployed, where they're deployed to, how they communicate with each other. Basically, we want a lot more influence over the way that these things are running. Now, it's not to say that you can't do that without the cloud, but it's something that is certainly a lot easier. I think there's also another aspect to it as well, that the building microservice style architectures in the cloud actually allows you to utilize more advanced features of your cloud product than you would with a traditional system. When you start to split up your application, as we're suggesting you do, it becomes quite easy, or well, maybe not easy, but easier to identify which bits should scale and scale differently. And you can start to make a lot better use of things like auto-scaling and on-demand instances, spot instances, all of that stuff that has always been there, but now we can make the most of it because we don't have to no longer scale a giant application. We can just scale the little bit that needs it. So I think they do go hand in hand very well together. They're probably not essential, but
yeah. A lot of people I know have restrictions about being able to deploy things off premises. That's changing, but there's still a lot of people that are perhaps regulatory reasons or other, they can't deploy to the cloud. Is there an alternative? What if I can't use the cloud?
So if you can't use any cloud, that might be an issue. I don't think you necessarily have to use the cloud. You don't have to be in AWS, but you do need a good level of automatable, cheap, fast virtualization. If you can get that from somewhere else, that's good enough, more than likely. If you have very little level of virtualization or control over that stuff, if you have a requisition process that takes 6 months or something like that, then you could maybe get away with either running multiple services on a box, but we know there are some downsides to that. You could maybe get away with running a few Docker hosts or something and having a mini PaaS set up. It's not going to last you forever, but it might be a good start if you've got limitations around using cloud products.
Yeah. Sam, I wonder, we hear an awful lot about Docker these days. It seems like Docker microservices, those are the two things that have the most attention right now in the world that we work in. Is Docker appropriate, and more specifically, is Docker appropriate for deploying services into production? Do you think it's ready for that?
I think the reason why people are so interested in Docker is very understandable. It does allow you to more densely pack those units of isolation I talked about earlier onto a single sort of physical machine or even virtual machine. And the spin-up time of Docker containers is really attractive. I'm less convinced by the argument that we should be reusing lots of images that people provide on the internet. I think the trust models around that stuff are not really worked out. But nonetheless, being able to build and host your own Docker images internally and just spin those up when required is a really attractive proposition. Is Docker ready for production? Yes, people are using Docker in production a lot. However, the thing to understand is that the tooling isn't necessarily there for managing lots of Docker instances. So if you think about a Docker instance, it's a place where I run lots of containers. When I've got 2, 4, 10, 15, 20 of those Docker instances all running different Docker containers, the tooling around that is fairly immature. We don't necessarily have sort of the cluster tooling is quite new, the scheduling tooling is quite new. So when it's not necessarily trivial for me to say, I want to run a container this size, find a machine for it to run on. So a lot of the organizations that are using Docker in production are either having to jury-rig that themselves or use tooling that's still fairly immature at this point. There's stuff coming from CoreOS, there's Kubernetes from Google, which all hold promise in this area. Docker themselves are slowly rolling out their own clustering and scheduling tools on top of Docker. They're all in alpha, so I wouldn't necessarily be using those right now. Likewise, Amazon have their own Elastic Container Service, which gives you a scheduling layer for Docker containers. Again, that's in preview. So by all means, use Docker in production if you want. Do your research, but just be aware that there may be quite a chunk of the tooling for handling across multiple machines that you're going to have to do yourself or deal with fairly immature tool sets.
Thanks.
I think that's quite an interesting point actually there, Sam, that I've seen on several occasions that people get kind of a false sense of security about using Docker, that initially it can be really easy to get started. Like you've got a single host, you're just pushing containers to it, launching them, this is great, this is going really well, I've got high hopes for the future. And then it dawns on you that you've just got a single host with all of your services running on, and now you need to get into orchestration and clustering, and all of a sudden it becomes evident that it's not necessarily quite a complete story there yet.
I know for a long time the scripted tools like Puppet and Chef have been sort of synonymous with DevOps. And we're hearing a lot about Docker now for deploying microservices. Do you think microservices changed the role of these tools, and what's the future going to look like there?
I think the role of these tools is changing somewhat anyway. I think we're seeing a bit of a natural decline in kind of the widespread nature of these tools like Puppet and Chef and Ansible and things, were a few years ago responsible for everything that we were doing in deploying services of any description. And slowly over the past few years we've started seeing the idea of baking virtual machine images. So we're moving that Puppet or that Chef run into something that occurs at development time or at CI time, whatever you want, whenever it runs. But it's no longer necessarily running in your production stack. So we're starting to see kind of where that lives in your process changing naturally anyway. And then I think as containerization has really started to take off, we're seeing the usefulness of those tools decrease as well. That where before there was all orchestration of everything, it turned down to creating a single server, and now it's creating a single container which can be summarized as a fairly short Docker file. I think combining that with what Sam mentioned before about spin-up time, the amount of time it takes for you to actually create an instance, especially when doing a Puppet run or a Chef run. You get your server, it boots up, it takes 2 minutes, and then you do a Chef run that takes 15 minutes. Containers become a much more appealing prospect when it can become near instantaneous once you've got your caches warmed and everything else.
We've seen some interesting questions typed in the Q&A section. I just wanted to take a question that I think is relevant to what we're talking about right now. One of our viewers asks about how do you manage lots and lots of microservices in this case. Like, it's fine to have those, and if the team evolves the number of microservices over time, everybody sort of gets comfortable with it. But then I've seen this myself as well, bringing new team members on to the team when you have lots of microservices, there could be a big learning curve there, understanding. Is there anything that can help to manage the scale of these things?
I'll take that one, I guess. I guess there's scale in lots of things. I mean, there's scale in terms of number of discrete parts that you may have. And then you'd be looking at things like, how do I find services? How do I know how they're configured? Things like that. And then really you're looking at some of the tooling in the service discovery space, like Console, that we might get into in a bit deeper a bit later on. There's also scale in terms of comprehension. So as a developer, as a human being looking at the system, where are all, how do I make sense of this whole big tangled mess of the world? I think environments where you have large numbers of microservices, a lot of organizations that handle them at scale don't necessarily have every point theoretically being able to see every other point. Often people will chunk up groups of microservices and present more coarse-grained interfaces to the rest of the world. So I might be communicating with a bunch of services around, say, my invoicing function. I just see a coarse-grained invoicing API. Behind the scenes, there might be 10, 15, 20 microservices handling invoicing. And so the ability then to actually chunk up those levels of comprehension help. The other level of difficulty, I think, for developers new to this stack touches back on the stuff that James talked about earlier, which is if you're shifting ownership models. If you're moving to a world where developers are building, owning, and operating their microservices, which the organizations that operate at scale in terms of number of microservices all seem to move towards over time, then you are asking your teams to have a broader range of skills. You now need to be able to know how to provision an instance, how to deploy it. And a lot of teams have central tooling teams that will provide scripts and capabilities that those teams can use. But in general, we're actually asking our developers to have a wider range of skills. So having some understanding about how do I run this stuff in a fairly fault-tolerant way, for example. I think in terms of how you get there, don't go from one microservice to 500. I would go from like 1 to 2 and then see how that goes for you, and then 2 to 10 and then see how that goes for you. If you look at stats coming out of REA and Gilt, when they look at their growth in microservices, they often have a very, very slow increase in the number of services they deal with. It's before having a sort of getting their heads around the new ideas, the new tools that are required, the new behaviors that are required. And once those things bed in, you see sort of this sort of hockey stick explosion in terms of the number of services they can provide with. But if you look at Gilt, for example, it took them a good couple of years to really get their heads around that stuff before they got to where they are now, before they had that explosion in growth and got to where they are now, where they have more than one microservice for more than 3 microservices per developer.
I know it's hard to know when things are running in production. It's one thing, how do we manage everything in the development and deployment process? But when things are in production and you have to manage these things continually, and you have to perhaps do some postmortem, some troubleshooting, figure out what's going on, it's hard to know what's running where. Are there any tools or any tips that you might have for how we can do that?
I think when it comes down to, I mean, there's part of that which is about monitoring and alerting. When you have a single, say, a more monolithic system, you only have 1 or 2 points to actually monitor, and you can actually go directly to those services and say, how are you doing right now? When you might have, for example, 10 or 15 different microservices involved in delivering, say, a single capability to a user, if that capability fails, you've got 1 of 15 different places that you need to go and look. So the secret there is you need to get information about the health and behavior of each individual service. You need to get that and aggregate that in a central location, and then have tooling that allows you to dive into that information when something goes wrong. So tools like Graphite allow you to collect stats, for example, and then look at those as an aggregated view or dive into an individual service. I think there's tools like Prometheus from SoundCloud that's very promising in this space, which is actually designed to alleviate some of the challenges that Graphite does have at scale. And so that's part of it. So, okay, if I'm getting all this information from my machines, I can have them in one central place. I can then dive into them. Things like log aggregation tools help here as well. Things like the ELT stack are definitely worth looking at. The other issue, though, is that's great. That gives me a lot of information to determine Has there been when I find out there's a problem, what could have caused it? But you also need to improve your alerting conditions. With a monolithic system, I could just look at the CPU of one box, and if that CPU is 100%, that's definitely a bad thing. If I've got now 50 different microservices running, and one of them is at 100% CPU, that may or may not be an issue. And so instead, we're looking at doing things like injecting synthetic transactions into our system that mimic user behavior to say, can a user still place an order? Can a user still make a payment? And these are sort of looking at the semantic behavior of our system. And then when those things fail, you can alert. Other organizations do things like looking at revenue deltas. Normally at this time of day, we would be expecting to make $100,000 every hour. We're actually, or every minute maybe, we're actually only making $50,000 a minute. That seems like a huge drop off from where we normally are. We need to do some investigation. And so you're having to step back a bit more from a monitoring point of view and put yourselves in the mindset of the user, and then using those layer level stats like CPU, memory, I/O, response times, error rates, to then actually help diagnose an issue once it's been identified.
Yeah, I know. I think tools like log aggregation and monitoring, dashboards, health check pages are necessary and great, but they do require you to know that the service exists. You have to put a log agent onto the machine. You have to know what the endpoint of the health check page is, and so on. Are there any tools that help us sort of discover services, or for services to advertise their existence, so that we don't have to have a central repository of knowledge about where they are?
Yeah, I think when you talk about service discovery, we can start off in the very simplistic world of convention-based DNS. So when I go to invoice.mycompany.com, that's the location of where my invoice service is. That breaks down pretty quick when we're changing machines frequently. DNS propagation times don't keep up, and so then you're in the world of sort of bespoke tools to handle service discovery. Traditionally, people would use things like Zookeeper for this. Zookeeper, though, isn't really a service discovery tool. It's really a distributed data store. But you would spin up a machine, you would say, hello, dear Zookeeper, I am running on this machine, and here's where you can find me. And then other services, if they wanted to find the invoice services, would look into Zookeeper, do a query, look for the name of the service, find the IP, and go and look at that machine. But Zookeeper wasn't built with that in mind, and so it has some shortcomings and isn't necessarily the easiest thing in the world to work with. A tool we like a lot in this space is a tool called Console from the HashiCorp guys. That allows you to sort of dynamically say, okay, hello, I'm here. You can then make queries via REST API to retrieve all the nodes that maybe make up your invoicing service. Console builds in the concept of health checking as well, though, which is really powerful. So it's not enough to say, I am here to Console. What happens if you crash, or you're slow, or you're taken out of service because you're decommissioned? Some service discovery systems will still report you as being there, and then you have to lay on top your own service discovery mechanisms. Whereas Console, you can actually build that sort of health checking into the service discovery tool itself, which means that Console will take things out of circulation if they're no longer responding in a timely manner. And that makes things like client-side load balancing driven by Console much easier. Now, I would say these tools rely on managing distributed shared states and having some level of consistency controls around that. That sort of thing is very, very difficult to get right. Some smart people have looked at Console. They haven't found any major issues so far. I do know people that are using it in production, but it is still a new tool. And if any of you know anything about cap theory out there, you know how hard it is to solve this problem well. But it's definitely a tool worth looking at.
I'll refrain from giving my cap lecture just now, but you can stay tuned for that in a future podcast. Yeah, Console's nice because it works with DNS, I think, as well. It's consistent with the standards, with web standards, and that's really good. We have a question here about that's a really good question and relevant to this topic. I think the question is, how do you build resiliency into your microservices? Do you put a load balancer in front, and how can you improve the 24/7 operation? Excuse me. When you're updating a microservice, so if you're having to deploy a new version, is there some way that you can continue to operate and be up while that's taking place? Do you want to take that, James?
Yeah, I'll give it a shot. When we're doing microservices, we're obviously going to be working with a great deal more dependencies than we would be used to, at least network-based dependencies that could actually disappear. I think we need to build that resiliency into our systems, and we need to make it a part of our development process, that we acknowledge that parts of our system are going to be unavailable. We're doing microservices, we're going to face things that we can kind of gloss over in larger systems, that things like network latency and network partitions, while they certainly can exist at any time, they become a lot more of an issue when we have a great deal of distributed systems. So make it explicit, make it part of your design process and your build process that you expect these things to be unavailable, and speak to your stakeholders, speak to your business people to work out how these things should actually operate in these scenarios, make them actual use cases. I have a system, the emailing process that sends off my invoices is down. Should I be able to submit an invoice for emailing? It's the call of the business to decide that. We need to bake it into our process. As to whether we should be having multiple instances and load balancing and things like that, for me, that's like a given if we're going into the cloud, even if we're not doing microservices. Availability zones in AWS can go offline and do go offline, and if you're not in multiple, that's a bit of an issue. So my default position is to have at least 2 instances of anything. That keeps me honest. Put them behind the load balancer, and then I have to, as a developer, not make those mistakes around keeping session state in my service and stuff. It brings those decisions forward. How you actually handle deployments, new versions, changes when you're trying to keep these things operating at all times. We can do things like blue-green deployments to handle zero downtime, but I also like the idea of actually just spinning up a sister service that does the same thing but is a new version. The old one sticks around for as long as realistically possible, and you divert traffic off it as other dependencies get updated. This idea that we don't want lockstep releases, so we don't want to just push out a new version and say, hey, anyone who depends on this, go and do a deploy as well. We keep the old version around, let them continue to use that old version if it's possible, and then as they migrate off, once we realize nobody else is using it anymore, then we kill it. So it's no longer a kind of push the new one, turn the old one off in a single atomic operation. That old one may continue to be around for quite some time.
Yeah, I think that's a really good point, that versioning is not always necessary. And I think in the microservices world, it goes back to how we build and test these things, but it's really important to have backwards compatible versioning and to be able to, and to avoid having to put a version in your URL or in your metadata somehow. We had a question that somebody typed in ahead of time into the question and answer box, and I think it's really quite relevant to this. It says, and the question was, what are the organizational prerequisites for transitioning to microservices? And what does a team have to do before it's worth trying microservices? What kind of a team do you have to have? And I think that's particularly relevant around the operation, maintenance, and deployment. Do you want to comment on that, Sam?
Yeah, I'm not entirely sure that there are prerequisites before you even start on this journey. I think it's more about an extent question. I think if you're running something in production right now, adding a second something it might be a stretch, but it's not necessarily going to require a wholesale shift in your behaviors. I think when you start looking at the need to adopt new practices, new behaviors, potentially even different organizational structures, it all comes down to a matter of scale. You can kind of see it that you've got lots of knobs and dials, and as you turn up the number of microservices, you're going to need to turn up the degree of automation you give your autonomy you give your teams. You're going to have to increase the amount of automation that you require and that you use. Your sophistication in monitoring and logging is going to have to improve to be able to diagnose failures in that sort of environment. And so I don't tend to talk in terms of prerequisites. I tend to talk in terms of there are pain points you're going to hit along the journey, and the more services, the more number of services you're running, and the more different types of services you're running, the better you're going to have to get at autonomy, automation, monitoring and alerting, and some of those learning challenges, some of those pain points are going to be worse for some organizations than others. For example, if you're already an organization that is using, say, a cloud-based provider or a provider where you can write code to provision infrastructure, then you're going to have a much easier time of providing the automation you need. If you're in an organization where you ship software in a very project-delivered mindset, where your reporting lines are based on the role you have, not the piece of software you're trying to ship, in that world, you'll start seeing organizational constraints based upon the amount of autonomy you can have. All of these things are going to hit different organizations in different ways. And so I don't see it as a prerequisite. And that's why, again, coming back to what I said earlier, it's also why I believe that you should start gradually in this process. If you have an existing monolithic system, start chipping it off piece by piece, and you'll learn as you go. If you're starting with a greenfield system, again, maybe you start with 1 or 2 services. Don't start with 10 or 20 or 50 and expect it's going to go perfectly well. I think it's more about being aware of the fact that decomposition of services is absolutely something I have in my toolbox. There's some great benefits I can get, and be aware, looking out for the possibility of when does it make sense to make that split. And then, break it out, reflect on that. Did that go well? Right, great. Then let's do the next piece.
I know we're talking a lot about the developers taking responsibility, building in resiliency into their applications. The developers building in the right kind of logging, monitoring, health check, and so on. Does this require a culture shift? Because for the developers to take ownership of the application beyond their initial project lifespan, that's maybe not everybody is up to that. Do you want to take that, James, perhaps?
Does there need to be a cultural shift in the organization? I think, yes, there does, ultimately. There will already be people in your organization that probably want to do this or will be open to doing this, and you need to look to those people to kind of lead these changes. That there will be people who are in your organization that aren't that interested in what else goes on outside of their little bubble. But there will be plenty of people who are, and if you take those, start to give them some responsibility, then they can really help drive these changes. If you empower people to actually make a difference, they're often very willing to do so. So it's more that the way that I've seen it happen is that organizations prevent people from doing these things rather than it's necessarily the people that don't want to do it. There will be people who don't, but usually it's that you actually can't get into production. It's that you actually can't look at the production logs. There are those limitations in place, and as you start to remove those, people will expand and fill the gaps that you have.
I think it is one of those things that if you're in an organization right now where as a developer you have very little power to make decisions, you're not involved in putting stuff into production, you're not, potentially a lot of organizations, not even involved in supporting the application you write in terms of You may have a different team doing BAU type tasks. Flipping the switch and saying, right, you're now accountable for everything in terms of deployment, in terms of picking up the pager at 3 in the morning. That's an awful lot of more stuff to take on. And I think if you make that switch overnight, you will scare some people off. And so I think it's important, if you are in an organization right now where your delivery teams don't actually have much power, maybe are part of a silo, that you gradually expand the responsibilities they have. Take them on that journey. And as James says, when people ask where do you start, I always do start with the people that are most open-minded to this. But I think it is about gradually expanding the amount of stuff you ask them to take on.
We had a question, another question that was submitted ahead of time that I think is really interesting. And the question was, from an ops management perspective, I'm interested in setting up measurable services for the business. In all my experience of doing this, I've aligned the service to a business objective. How does this work in the microservice world? Are there ways that we can gather metrics, that we can align our microservices with the business intent?
Yeah, that was a question from Brooke, wasn't it? I think a lot of that falls out naturally for those organizations that have moved to sort of more of a product-based thinking. So if you think about a traditional IT operation, some bright spark in the business is always in air quotes, some bright spark in the business has an idea about how to make some money or how to make customers happier. They then give a set of features to the IT department, who then spin up a project based on funding to deliver that, and then they give the software back, and hopefully the customers are happy. I think with those organizations where the person who has the idea controls the budgets for that idea and effectively also owns the priorities of the delivery teams directly, then those things become very tightly aligned. That's a shift we've just made recently inside ThoughtWorks, actually. It's one of my responsibilities looking after that. So, for example, our head of sales, he has to go and ask for money to build out tools to help him around sales. He works with the team to prioritize their workload. He explains what's important and what's required. And those are the metrics that the team uses to judge their success. I think the more space, the more gap there is between the person who has that business focus and understands what it is that makes a customer happy and where your IT delivery is done, the harder it's going to be for your IT team, your delivery team, to really think, okay, this is what we need to be tracking. And so I think breaking down those barriers is really, really essential. Like if the person who understands how to make your customer happy is sitting in a different office on a different floor from the team actually delivering the software that's going to make those customers happy, that isn't necessarily going to make things very easy. Making that shift from project to product-based thinking will deliver a large amount of that change, but for many organizations that can be a significant journey, especially as it can play into how money is allocated in larger corporates. Unfortunately, sometimes the biggest constraint seems to be funding models. There is some stuff in the Lean Enterprise book from Jez, Joanne, and Barry that may be of interest in that. But I think any general book on product-based thinking may well help.
Thanks. I'm seeing the questions that we're getting. We're getting a lot of questions that are sort of generic or that are kind of fundamental questions about microservices. And it's given the amount of interest and questions that people have, it's probably worth us going back and addressing some of these things. You can watch. There's a lot of other places that you can go to get that information as well. Sam's book. There was I did a Yao presentation. There was a good Yao presentation from REA. So we also have a workshop, a one-day workshop that many people have attended. But just there's one question that comes up a lot, and that is and let me read this. My big problem is the database, because the software was made based on multiple queries in the same database. In your opinion, which approach could be better? If we want to, how do we deal with data? And I think maybe we go on to talk about how do we deal with data when we're doing the deployment. I think it's also relevant to deploying.
Data is a very interesting and difficult topic with microservices, especially if you're introducing them to an organization that already has a well-defined structure in place. Often, I think what we're talking about when we say the database is the problem is that we have a database, a single database that backs our entire organization, and it is a monolith in itself. And yes, we can start to hive off bits of functionality from the system in front of that database, but ultimately there's a lot of integration going on behind the scenes as well. And it's not an easy thing to solve in any stretch. The ways that I've seen be at least a good way to start dealing with these things is as you hive off bits of functionality, so you identify a part of the system that is kind of distinct from the rest of it and you pull it out as a separate service, if you can, I mean, ideally you take that part of the database with you, but that's maybe not possible, otherwise we wouldn't be talking about this. I like to try caching data. So it's not going to work for everything, but if you have a data store within that service that simply acts as a cache of what is in the main database, you get some degree of separation from the main database. And over time, you can pick these things apart while your service is still happily living off with its own set of data that is being synced however you choose. It just gives you a little break point. It's not quite a clean break from the database, but it's a good place to start, I've found.
I mean, I'm very firm on this because this database integration is the most common integration pattern that we see. It's also the most dangerous. It's the one way you can ensure that you can't evolve services independently from each other because you can't make changes safely to schemas. If you're looking to break apart an existing system, say an existing code base, you have to separate the data before you separate the service, in my opinion. If you're already in a place where you've got multiple services reading and writing from the same database, you've already got an integration point that's going to make independent change very, very difficult, and you need to resolve that problem first. It isn't necessarily easy. It's the hardest thing there is actually about decomposing existing systems is around breaking apart those changes. But you have to have the concept of services owning the life cycle of the data that they represent and they hold. You should have no database access. If I want to get some information from a service, I go and talk to its API. I talk about this a lot in the book, but it can be a very poisonous integration technique. And it's very easy to start off that way. Lots of people start spinning out microservices. They take some code out of an application stack, but they're still reading and writing from the same database. That's not going to last for very long. It's very, very important that you avoid direct database integration between services, especially for reading and writing. I think there are some specific use cases where it makes sense. I think when you start looking at cross-service reporting requirements, for example, you need the ability to run some queries on data joined from multiple sources. So how do you get that data? The way I'd like to think about that is it's the job of the service to publish data into a centralized reporting database, rather than saying my reporting queries are going to reach inside the service and look at their data store. So instead, I might have one database that I use for running a live service, and it's my job to then propagate that data into a centralized reporting schema. And that gives you a nice degree of separation. I think I talk a lot about the patterns around splitting services apart, handling cross-service data in the chapter 5, which is actually also the free chapter that we make available from the ThoughtWorks website.
Yeah, I think that's a really good point about starting to split up your data access in the application before you split out microservices. If you're accessing a lot of data and integrating your application through the database, you probably need to fix that before you jump into microservices. You need to start factoring your applications so that they communicate through abstractions rather than directly to the database. We have a question here and that also comes up a lot, and that is, how do we deal with legacy systems? And if we want to go to a microservices approach, but our business is run on big ERPs or other kinds of big packaged software, how can we manage that? James, do you want to take that?
I'll give it a shot. Yeah, we see a lot of these kind of systems in the places that we work. Most organizations will have some system that is a CRM or whatever they do with their business, and it'll be a central store that people use, and that's not going to change anytime soon. Seems to be the common theme, that integrating with it is painful, but it does serve a purpose and people are using them relatively successfully. How do they fit into microservices? The way that I've seen it used in a few different places is that these systems tend to have multiple responsibilities. Rarely have you got a single package that does one thing. You've bought a system, Salesforce or something, and you've tacked a few different extensions on there. What we do is, or what I've done in the past, is to create little services that represent particular pieces of the backing system. So you may end up with multiple microservices that just represent or front the billing portion or the data entry customer maintenance section, or you end up with multiple microservices backed by this legacy system. So the rest of your organization, the rest of your services, don't really need to know that there is a big unwieldy CRM sitting behind things. You can still nicely communicate over HTTP with your hypermedia APIs and all those good things that we like, without having to have your CRM ominously sat in the middle of it, influencing everything that you do. So this idea of creating little services that sit in front of distinct portions of a larger system behind the scenes.
We have another question here that I'll resist answering myself. What is the future of ESBs like BizTalk, web methods now with microservices? Do you think that are those compatible? I know a lot of people say a service bus is necessary for microservices. Do we need that stuff, Sam? And what's the future of it?
Yeah. So I think when we talked before about what microservices were, we talked about this idea of autonomy, that these services need to be able to change and evolve independently of each other. That actually leads from an architectural point to wanting to devolve smarts into those services themselves. We want the services themselves to have the smarts, the intelligence around some aspect of the domain. One of the temptations can be when using middleware, things like the enterprise service bus, is that you start putting behavior that talks about how the system should behave into those centralized points. And so you end up with enterprise service buses having lots of smarts around how things should behave. Those sort of service buses can end up then becoming a coupling point. All my logic as to how information flows through my systems about how domain objects may be modeled are in this one giant centralized tangled mess of a service bus. And we've seen this for the last 10 years being a huge constraint to rapidly changing software. In general, I have no problem with a message broker, something whose job it is to get a message from A to B reliably and in a resilient fashion. I think that's a perfectly sensible thing to do, but I think that's all that those sorts of technologies should be used for. So by all means, use IBM's MQ series to drop a message on a queue and have subscribers gobble that message up afterwards. But that's as far as I would take it. We like to think about the smarts being in the endpoint and our pipes being dumb. And that's a way to really sort of keep that sort of behavior of our system sort of in a single cohesive unit that can be changed and evolved in one place, rather than having sort of everything sort of wedged into these big giant enterprise service buses that are very hard to change. And so I think the that can also play into the role of things like business process modeling tools, where people will define workflows for how a series of things should happen, maybe as part of a business process. Those sort of workflow-based tools, again, themselves end up becoming the sort of centralized point of authority, telling everybody what to do. And in that world, your services can often be quite anemic. You've got this giant central brain then that becomes the single bottleneck for all behavior. Rather than that, we sort of prefer an approach, sort of often what's called a choreographed-based approach, where services understand their part of the flow. They don't necessarily need to see the whole flow. They just know that, okay, when this happens, I perform this action. Because that not only ensures that those services can change independently from each other without having to change this centralized sort of giant brain, but it actually also allows those developers who are looking after that service to not necessarily have to deal with, say, the complexity of what might be a much, much bigger system.
I also find that service buses, message queues, all these different ways of integrating services have a tendency to be to spread and become pervasive. Like, you often find organizations where they go in and the only form of communication is over some form of message queue. It doesn't even have to be a service bus with smart routing and everything like that, but you find that, you know, we communicate over a message bus. As somebody who is quite vocal about largely only using HTTP and web style technologies, I've liked the approach of if you find that a queue is a good fit for the kind of thing you're trying to achieve, to place that behind the front of your service. So other services don't need to necessarily know that you're using a queue. You can still be using a queue behind the scenes and using that as a way of creating some resilience, but you don't need your consumers to have a RabbitMQ client within their integration. I found that useful.
I think that's a good point. I hear a lot of talk about asynchrony being necessary for microservices, and I think adopting asynchrony everywhere is probably overkill. So we only have a couple minutes left. We're coming up on the hour, so we want to wrap up. I want to remind people, if you have, the link will be up so you can watch the replay of this. And if you've had questions up there that didn't get answered, we will go through and try to answer those online after this. Just a final wrap-up question. If people in their local markets, say Sydney, Melbourne, Brisbane, are interested in this topic and they want to get some local support, are there any communities out there? Is there anywhere people can turn to try to get a little more information about this stuff?
So, being Sydney-based, I'm obviously very biased towards the local community here. There is a local Sydney Microservices meetup. There's been some interesting talks happening there. It's been going for a couple of months now, 3-4 months maybe at most. But they meet about once a month. And there's always a really good showing there of people and some interesting topics coming up. So definitely get to that one when the next one occurs. There's also, I think it's quite important for me, microservices have loads and loads of different moving parts, loads of different technologies and things coming together as this single idea. So I think it's really good to get to things like the DevOps communities, because those practices are essential in achieving this stuff. Get out to other language groups, find out how the Golang people are solving their deployment problems, and get to different community groups. So in Sydney, my big ones are the microservices one, the Golang group, the DevOps group. The Node group is always good as well. Like, I just make sure you're across a wide range of different groups.
Yeah, and I know there is a microservice meetup in Melbourne as well. So yeah, do a search on Meetup or wherever else. But these events are spinning up, and if you happen to be in Perth or Brisbane or Adelaide or Canberra and there's no microservices meetup, then well, why don't you make one of your own? And if you let us know via Twitter, we'll do what we can to spread the word.
Go speak at these things as well.
I suppose we need to wrap up. The hour's gone really quickly, and I've enjoyed it. I hope you have too. We want to remind people the recording will be up there. We will send a follow-up email to everybody that registered with, it'll have a link to the book page and a place you can download a free chapter of Sam's book, the one he mentioned. And if you have more questions that come up, we'll try to monitor this page and see if we can answer them. And I just want to put in a plug for the ThoughtWorks Tech Radar. Sam and I are both contributors to that. Lots of topics relevant to microservices are on the radar, and I'm sure we'll be on the next one as well. You can get that at ThoughtWorks, www.thoughtworks.com/radar. So thank you, everybody. Thank you, James. Thank you, Sam. And we hope to see you here again soon. Bye.